So my name is Clint. I'm a designer from a company called Scala, and I have the impossible task of following that up. This is made more impossible by the fact that I just finished this slide deck about 3 hours ago and have not run through them at all. So we'll see how this goes. Bear with me. This talk is called Scala for JavaScript Kiddies and JavaScript for Scala nerds. And it's kind of about taking the lessons that we can learn from a language we love dearly, despite its many flaws, and applying them in different ways. And I'm going to open by saying that nothing you see here is going to be new. We're going to talk about an application framework that's pretty old, and we're going to talk about a real simple abstraction. And I'm pretty sure nothing here is new. And that's not going to be the point of the journey. So what's the point of the journey? What are we talking about? Well, we're talking about this thing called Janus, which is an application framework that we built at Scala. We're going to talk about what it is. We're going to justify its existence because we should do that. Talk about where it came from, the consequences of decisions that were made, and then close with some difficulties around trying to take a functional thing and put it on top of JavaScript. So what exactly is JavaScript? Well, it's a web application framework focused on organization of interface code into reusable pieces. It's not an application framework that cares about networks or databases or any of that stuff. It's just about organization. But there are a lot of things that do this in the JavaScript world. There's Backbone and Angular and all these hip things that are out there. So why does this thing have to exist? Why did we go and build this? And in order to explain that, I kind of have to talk a little bit about the company I work for. And I promise not to shill too much, but we are hiring and we do a lot of Scala and we have a lot of really cool projects. We have a JSON library that is completely reflection free, and if you didn't look closely, you would swear that was black magic. But that's not the point. The point is that our company uses data and technology to improve informed governance. And that means a lot of things. We have a really cool data API. We have a really rich application interface. But the key point for this talk right now is that word governance, because it means we work with city governments, state governments, and federal governments. And that means that we are beholden to certain regulations and laws. 508 compliance is accessibility. What it means on the web is that by the time your application hits the user's web browser over the wire, before JavaScript has loaded, it needs to be consumable. And the big problem is that most of the JavaScript frameworks out there don't care about this. They don't look at this at all. In fact, the routing library that I actively use to power this framework says explicitly, if you're trying to use this on the client and the server together, you're probably doing it wrong. Well, no. We're going to try to make it work. And it turns out that making things work for 508 also tends to make them work for SEO. So this is something that we're interested in. Now, right now, the way we deal with this at the company is we write everything twice. We write it once in Ruby, we write it again in JavaScript. And that makes it very difficult to build a coherent code base that actually provides rich interaction without sacrificing quality. So let's talk about sort of the principles behind the framework, because if we're going to define something new, we need to make sure that we're doing it in the right way. So, of course, the top priority, as I just mentioned, is reusable code. The same code should run on a server, and it should run on a client with almost no modification. There should be no if server, if client checks, if possible. Next thing, it should be componentized. Different parts of an interface should function together, and you should just be able to compose them together. And if you're going to do something multiple times, you should be able to call it again and again. And this is something that, like, you know, as JavaScript programmers, we didn't figure out until about 3 years ago. So, you know, that's pretty cool. And a cool result of being componentized is that things are more unit testable. That's also something that JavaScript community is just sort of figuring out. And last but certainly not least, it should be live-bound. The framework should do the work of making sure that the state of your interface is the state of your world. You shouldn't have to do that work yourself. And that's also something that is kind of new with Backbone. And Backbone gives you the tools to do that, but doesn't take it all the way and make the opinions that it needs to in order to make it automatic. We'll talk about some influences. So jQuery is, of course, the JavaScript framework for manipulating the DOM. It solves the DOM insofar as it can. No interest in replacing that. Use it as much as possible. Backbone is, as I've mentioned, sort of the preeminent organizational framework. It provides an MVC idiom, and it has a lot of really well understood principles and practices. No interest in trying to supersede what it does there. And finally, D3 is something that I just hold near and dear because secretly it is a declarative and functional system. Most people don't realize that when you're using it because they're JavaScript programmers and they don't think about those things. But secretly, when you're using D3, you're declaring that this piece of data should be drawn in this way, and you have no state in between. So that's pretty cool. So, Scala. I'm here at a Scala conference. Where's Scala as an influence? Hadn't crossed my mind. Didn't even come up, not even a thought in my mind. And we'll see how we get there. So let's examine some of our goals. One of our goals is that our framework should be live bound to HTML. And you kind of look at this as like one possible set of HTML that you would have. You have like a class where a person is new, right? That person is new, and that may change over time. That is a state that could change. And you look at the way HTML is formed, and that's kind of a difficult thing to principally change, because when you ask the DOM for the class of this div, it's going to tell you person space new. And that's not a very easy thing to manipulate. And you'll also look over here, and let's say we have a string colon some other string. That's also another thing where, short of using bracketed templating, it's very difficult to express what that means. And when I looked at this problem and tried to solve the idea of running a piece of code on the server that generates a set of markup, generates a set of state, and sends it down to the client and attempts to use that state seamlessly, then you start going, well, this stuff better be idempotent. This stuff better work the way it should, no matter what the existing state of the system is. And that is sort of restriction number one that leads us down the path. Let's talk about the model side of things. So this is how Backbone does stuff. There's, you have a person, you can get stuff out of it, you can set stuff into it, and then they have sort of an event-driven data model. So you can go through and say, well, if the first name changes, I want to do some imperative thing. And then so I modeled after that. If you get a person, the one change is you can nest into objects because they didn't bother to deal with that. You can get a person's name first. You can set the first name. And then I kind of did this thing where, well, you can watch a person. So instead of just being event-driven, I give you a thing that encapsulates some state. And so person.watch gives you a thing that encapsulates state that changes. You can do a name.first. And then I just as an afterthought almost threw in this little thing where, well, maybe you want to transform it. Maybe as the thing changes, you want to get something else. So my friend Lily really likes putting exclamation point after her name. So maybe that's something we want to do often. This is something I built in. So now we talk about mapping these two things together. So you have a template. Here's a fragment of HTML. There's no bracketed templating inside of it. And then you have a binding. So a binding is what takes the state of your model and maps it into that DOM. And here you can see that we take the first name, the first name class, which does not actually say first name. It says .name. So we're finding that div that is incorrectly named, and we want to set its text from the first name and the last name, and given that I have this thing called flat map, and you take name and the first and last, and you're thinking to yourself, that's not a flat map. And that's absolutely true, because I was coding this at 2 a.m. and couldn't think of what to name it. So I said, well, what's the most confusing thing I can think of? So I called it flat map. And that's a joke, but that word is actually what then triggered the things in my brain to start thinking about this. Because when I was learning Scala, that was the first time that I had really seen the concept of a map being used on something that wasn't an array, right? Being a JavaScript and a Ruby programmer, you see map a lot. But it's always just, well, I want to do these things to this array. You think of it in terms of arrays. And it turns out that, well, mapping a single object is a perfectly valid thing to do. So knowing that and having made the realization, I went back to the object I had that encapsulates state, called a varying, and added map to it. Now you can see here the existing things. You can create a thing with a value. You can just imperatively set value on it. That's not a big deal. That's fine. And then on change, we can handle some things. So I had a map to that. So you pass in a function, and it'll give you a new varying that will take the existing one, map this value, and every time it changes, emit the same events with the new value. And then I kind of thought to myself, well, is this a monad? And bear in mind, this is the only time you're going to hear monad in this talk. And I kind of thought, well, you can put a thing in a box, and you can take that thing and put it in another box. And I actually auto-collapse varyings together, which sounds really dangerous, and it's only burned me once, surprisingly. And I was like, well, maybe it's a monad. And I spent about a week trying to figure out if it was or not, because I'm not the best at this stuff. And eventually I went, well, who cares? Because the audience for this framework doesn't know anyway. So it seems close enough that the safeties it guarantees and the things it represents are probably there. And if somebody bothers to correct me about it, I'm happy to take it. But that's kind of what happened there. And this varying class ended up being sort of a key to the whole thing. Here's the whole thing. This is an overview of the main components that comprise Janus. It is actually a very small code base in terms of lines, but as you can see, there are a lot of things here. So, first thing we'll talk about is a model. We kind of already covered it. Here's an example model. You have a person, extends model. There's a thing called bind. If a value is explicitly based on some other values, you can just sort of bind it. So if I always want the full name to be part of based on first and last, then I just take first and last and concat them together. And to Paul's point earlier about restriction, JavaScript does weird things with this. When you're in a function, you can sort of rebind the keyword this to whatever on earth you want. And so when we're inside of this, also incorrectly named flat map, this is just nothing. You're not allowed to access anything else. You're given the things you declared, and that's it. And that's sort of a very simple restriction put in place to make sure people are on the right path. And the whole time I was writing this, I kind of had to choose a line between being overly restrictive and guiding people on the right path. And here's one case in which I chose to be restrictive. You can also just declare any random methods, of course. And the right way to do it in the framework philosophically is to make everything be based on a varying. So if I want to check if something is of age, I don't return true or false. I return a varying of a Boolean. And so I'm watching age and I'm mapping it to see if it's greater than or equal to 18. That's not so hard. We have lists. Lists are pretty cool. These are, again, largely based on backbone ideas. So you have people. We declare that the thing inside of it is a person, just so that we know what to do with the things inside of it when we try to serialize or deserialize. I threw in this last element just to show that you can watch at an index. So for example, if you want to watch the very last index, that will always be there. And then the interesting thing about the list here is that it has these familiar looking filter and map things. And the thing that accepts is also a varying. So if over time a person becomes of age, we're going to automatically update the list to contain those new things. So you declare what you want to have happen, and the framework takes care of everything else for you. It's not obviously correct, but it's getting there. All right. Attributes are just little bags of behavior. This is wrapping poorly because the projector is small. But you can see that we can map alive as an attribute and define some behavior behind it. And here you can see I'm using sort of this anonymous class thing. And like in my brain, what was screaming to me was traits are pretty cool. And so that's how that came up, because it was a lot easier to do it this way than to come up with a bunch of random functions to pass in. So here we can declare that alive is by default true. An issue is an interesting thing. So a difficult thing in front-end frameworks usually is trying to come up with how do I validate things in a way that makes sense, because this thing might have 10 validation errors and this thing has 3, and they're all different, and I don't want to have some central repository of validations. And it ended up being easiest to actually just concat together a list of possible issues and flag them as whether they're active or not. So based on the earlier facilities you saw for filtering and concatenation, we can just declare that a person's age has possible issues comprised of this list. And here's one possible issue, which is it is an issue, it's active, if the age is less than or equal to 0. Well, that's not what it says, but that's okay. It is very severe, and here's the message it should say, which is, given that age, the age is not valid because it's less than 0. I forgot to actually put the age in a string. But you get the point. And these are all concatenated together onto the model itself, and then you have a list of issues that may or may not be active, and they're filtered on that. A view. So a view manages the interaction between model and presentation. And Here we see one, we use jQuery to do some things, and here you see an imperative thing. This is extraordinarily imperative, and this is why this class exists alone in itself. All it does is declare the behavior of interaction. And so you can see that here we're trying to find the delete link. When you click on it, we prevent default, which is a silly front-end thing you don't have to worry about. And then we destroy the subject. And that's a very imperative thing. And we try to limit all of the imperative things to this class. And that's sort of how we achieve being able to do the things we want without burdening ourselves with a lot of machinery. So a view uses a templater to actually do the binding against a fragment of markup. So here you see we declare that the DOM is based on this thing of markup, that the implementation detail doesn't matter. But more importantly, you see that we have a binding. And the binding here, we're finding the person div. You saw a little bit of this earlier. And we're declaring that it has the class of age, depending on whether the age is greater than or equal to 21. Make that fit. Depending on whether the age is greater than or equal to 21. And this goes back to the idempotence thing, and it also goes back to the functional and the restrictive thing. When you're in that method, or when you're in that function, you have no access to any state of the world except for what you declared you wanted to use. And whatever you do maps directly onto an idempotent action upon your markup fragment. And then you can see we can also take some text from the full name, and we can also render a view, another view, based on friends. That's sort of the templater. And the templater just contains a bunch of binders, so you just saw that. So that's that thing. So how then do we manage state that is purely view-based? Well, we just create another model. So if you have state that's just in the interface, for example, if you want something to be expanded or not, just create a model, and then you can nest the thing you actually care about inside of that and access them just as easily as you'd access the attributes themselves. And then you can map against that very easily. So now we get to the one part of requests, or one part of networks that we care about, which is often when you're coding, you need to refer to something that's elsewhere. That happens kind of a lot. And so, I thought about this problem on a very long walk home once and tried to figure out how to make it fit in the framework, and I went, wait, this varying thing indicates something that can change over time. And a future is just a thing that changes at some point in the future. So I kind of already have a future. So all a request is, here you can see an initialization or an implementation of a specific request. All a request is, it extends HTTP requests, which in turn extends varying. And so it is just itself a varying, and it might have one of these possible values, one of these possible classes as a state. So it might be init, it might be pending, it might be success, it might be error. There are more that aren't listed here. And here you can see me thinking to myself, case classes are pretty cool. I want to be able to pattern match. And so that's where that came from, and being able to do that sort of thing. And we'll talk about the consequences of that decision later. And then later, and down here you can see that in order to actually use that request, once we've handled it, all we have to do is just say, well, take what we've succeeded to be given that varying depending on whether the value inside of it is successful, and then we can map into that success if we want to get a value out of it. The store is just the thing that imperatively handles the request. So we have an HTTP store, it handles a thing, does a bunch of imperative async stuff, which is, in this case, just all AJAX. And then at the very end, it imperatively sets the result of the request. This is okay. We've, again, taken all of our imperative stuff and boxed it into one place. And that's really the goal here. So you can see in a sample usage of a store is just, well, here's my request, and given some store library, I'm going to get the appropriate store for that and handle the request. So what on earth is a store library? Here's where the part where we're in JavaScript is really awesome, because types are just kind of whatever in JavaScript. It's Wild West, you can do whatever you want. So what a library is just a type-based system, an inheritance-based system that just reflects all over the place and then determines, given this object, what do you want to do, what do you want done with it? So you can, for example, in this case, make a new library, doesn't care what's inside of it, and we're going to register that any model can be rendered using a general model edit view in a context of edit. And now if we try to get a person for context of edit, we're going to get, let's be on the same line, we're going to get a general model edit view. And this is really cool because this is what ends up solving the divide between the front end, or the client and the server. This is what enables us to create a set of components that handles the appropriate thing in one place, handles the appropriate thing in the other place, and puts it all together in a way that you're not if switching, because you just register a different set of components in each environment. And here's where JavaScript has a major advantage, because we can just be completely cavalier about this and not really care. The compiler is not going to throw a hissy fit at you. So that's sort of the overall stuff. So here we kind of put it all together. So if we write stuff here, you can see I've got an edit renderer into an attribute. It binds against that fragment of DOM on the right. We're going to give him a name. We're going to say he's negative 52 years old. And oh no, negative 52 is not a valid age. It's less than 0. So we can go back and fix that. Or we could introduce another error, which is like, oh no, first name cannot contain a number. What kind of name is that? And so this is sort of all of the pieces briefly working together. So let's talk about some problems with this whole endeavor. The first one is NPM. NPM is the package manager that powers Node. It is extraordinarily pedantic. If two different modules reference the same module, even if it's the exact same version, it instantiates a completely separate instance of it, which there are great reasons behind doing that, mostly learned from the Ruby community. But now you have a problem where I'm doing things like X instance of Y with those pretend case classes earlier. And suddenly Y is not the same depending on whether I'm in my project or in my application. If I have two things that both rely upon Janus, suddenly I have two ideas of what a success state is, two ideas of what an init state is. And there's really no way around that. So right now I actually just export Janus to global. That's the only way I could figure it out. So we're fighting NPM with type-based comparisons. What's another problem that we have? Well, lying to the user is something we have to do frequently. For example, earlier you saw that when I took away the validation error, the thing on screen disappeared immediately. That's not a very good sense of indication. You should be able to see that you succeeded, and then it should disappear a bit after that. But because of the way that this is all functional and tightly bound against the truth, there's no way to be like, wait, hold on, lie to them for just a bit. So I created a framework called lie. You can see. Here's how we would do, for example, the nifty thing in Facebook where you hover over a link and it appears a little box, and then if you hover off, it disappears, but there's a delay on each side. And here's how you'd normally do something like that in JavaScript. You make a timer. You'd say, well, here's my view. Here's my link. When you hover over onto it, I'm going to clear that timer because you just hovered onto it. I'm going to set a new timer, and then when that timer expires, I'm going to show a pop-up. But then when you hover out, I'm going to clear that timeout, and then also maybe destroy the view. There's about 6 different bits of state that are happening here that are all entangled together into this piece of code. And how can we use a simple abstraction to clean that up? Well, here's a varying-based version. They are hovered or not. That's just true or not. And you can see we declare hovered, and then on the third line there we say, well, when you hover, set it to true, and when you unhover, set it to false. That is the truth. And then we apply a simple abstraction to lie to the user. So we use a sticky liar, and I lost that screen, but not that one. Okay. And if it's true, we'll lie to them for an additional 800 milliseconds that it's still true. And if it's false, we'll lie to them for an additional 400 milliseconds that it's still false. And now we get that delay behavior without polluting our own code base with 6 different kinds of state. And so then we just react on that varying, and then we show the view if it's true. The implementation doesn't really matter there. What's another problem with doing this sort of thing in JavaScript, doing real functional stuff in JavaScript? The language hates you. Can anybody tell me why this would fail? This is a valid thing to want to do. You want to reverse a series and show it to the user, but why would this fail, do you think? It seems pretty obvious that it should work. So the answer is that reverse both returns a reversed array and mutates the original array. And this was a bug that cost me a whole day. The language absolutely hates you and does not want you to use it in that way. What's another reason the language hates you? Well, there are no compilers. There's no compiler, and there's no types. Janus, the framework, is pretty small. It's a small piece of machinery, but it runs deep. And because of the way it sort of accepts declarations and just does whatever it wants with them, means that if you make a small mistake with what method you're calling or what you're passing into something, it takes a really long time to dig it all out because you have to dig into this big piece of machinery. Gee, wouldn't it be nice if it told me if I was passing in a string instead of a function and I was doing the wrong thing? Another bug that cost me a full day. So that's another problem there. And then the last thing is that it's real tough to debug because if you have an imperative framework that manages a bunch of state for you and you try to put functional stuff on top of that, what it means is that by the time you've cascaded down to your very last map of your very last varying and you're like, here's the problem, you've lost all of the other functional things that were entangled inside of this imperative framework code. And that's actually one of the biggest problems is that the last problem compounded with this one means that your end code is real small and compact and it's functional and you can see that it's correct. But it's impossible to figure out what went wrong if you did do something wrong. And that's because maybe we're thinking about debugging wrong. And here's, this is early work, where by early I mean I started it 7 hours ago, and by work I mean clearly it doesn't work that well because I can't get D3 to render at the size I wanted to. But in case it hasn't become obvious yet, this deck is actually written in Janus. The entire thing is a deck model with a list of slides, and then there's a current slide that's based off of a watch of the very last slide, and each slide is itself a model. So here is a rendering of the actual current state of the system. You can see that my deck is down here, right there, deck. And I've got a current based off of that, which is my current slide, and you can see it's currently entangled with 18, which is the number of this slide. You can see back on slide 12, when we were messing with Jebediah's name, we created a person, and that person's name was Jebediah, and they were 52 years old. This is the actual current state of the system. The next step is to actually be able to go back in time, have a slider that shows you this happened, then this happened, then this happened, then this happened. And that's a much better way to look at a whole bunch of functional code, is just what happened. I don't care about the lines themselves. I just want to see what happened and how those effects cascaded through the system. So that's all a big trip through a system. And the system itself doesn't matter. I tried to emphasize every time I did something with influence where that influence came from. And of course, a big part of that was my time with Scala, as hopefully you gleaned. But I'm going to go back to a claim I made at the start, which is that nothing here is new. Right? These are all very simple things. Functional reactive programming is not new. Now, usually it's based on event streams rather than the actual end value, but I'm very certain that talking about the value is not new either. What's new is taking a bunch of different influences and putting them together. It feels new. And so here's the point of the entire thing. Don't ever be satisfied. Don't be satisfied with your own knowledge. That's obvious. But also don't be satisfied with your own community. If you have a lot of different influences, it's going to teach you different ways to think about problems. Sometimes something as simple as joke naming a method flat map at 2 a.m. can spark an entire series of effects. And don't ever be satisfied with accepted practices. And this is something Brett Victor says a lot too. You should program things and you should build things to work best in the medium that you're talking about. If debugging is hard with a line debugger, maybe line debugging is wrong. Maybe you should be doing some other thing. In the theme of never being satisfied, there are actually several things I wanted to put in this slide deck that I just didn't have time to. And when this slide deck goes online on GitHub, which it will in the next few days, there will be more in there, so I encourage you to check it out. But for now, thank you very much, and I'll take whatever questions you have. It is open source, and the license is WTFPL.
So, a whole bunch of JavaScript. How is that search engine friendly?
So what friendly?
Search engine.
Oh, search engine friendly. So I didn't emphasize it because it wasn't the point of this talk. The point was influences in Scala. But the same pieces of code are capable of running on a server and on a client. So the server will generate a piece of markup through this system that you just saw. and that piece of markup is dropped into the web browser, and the exact same piece of code will then on the client pick it up and go, oh, hey, here's markup, and here was my model state on the server. I can trust that the state of the markup is accurate to what I want it to be, and I don't have to re-render it. I can just pick it up and start binding the same kinds of state transformations against that DOM that I would want to directly.
So looking at your reactive demo, the first thing I thought of was Elm, which I've been seeing.
Yeah,
recently.
yeah.
So, I mean, obviously you're in JavaScript and staying more, in that realm as opposed to building a new language. How would you compare and contrast like your approach versus, say, like Elm's approach?
So I am familiar with Elm, and I spent some time with it, but it was one of those things where like it was very high concept, and I couldn't really get into it. So honestly, if I were to name a difference, that would probably be it. Is that this is meant to be just very. That's my timer telling me that my presentation is done. It's meant to be accessible and familiar to the way JavaScript programmers want to work. There are a lot of chaining APIs, some of which I actually want to get rid of because those are mistakes. But that's something that's familiar to JavaScript programmers. There's a lot of anonymous functions being passed around, and that's something that's familiar. So I would name that as probably the biggest difference. Cool. Thank you very much.